All right, let's crack a type of math problem that shows up all the time on competitive exams. Now, it looks pretty intimidating, but I promise by the end of this, you'll have a superpower to solve it in seconds. Okay, let's dive right in.
So here's the challenge. Picture this. You're in an exam, the clock is ticking like crazy, and you see a question that looks like it needs a calculator and at least 5 minutes of your time, but you've got less than one. What do?
Just look at this monster. Find the remainder when this huge product is divided by 17. Now, your first instinct might be to actually multiply 1736 by 3488, and then multiply that result by 17.2. But let's be real, that is completely impossible without a calculator, especially when you're under pressure.
And you know what? That's the trap. The exam isn't really testing your ability to do massive, painful calculations. Nope, it's testing if you know the smarter, more elegant way to get to the answer. It's testing you for a shortcut.
And that shortcut is a beautiful little concept called the remainder product rule. This is the key that unlocks this entire problem and turns it from a total nightmare into something you can pretty much solve in your head.
So, what is this rule? It's actually incredibly simple. It means we can totally ignore those big, scary numbers. All we really care about are the small, manageable remainders you get when each number is divided by 17.
Let's put this rule into action with our first problem. We're going to break it down into a really simple, step-by-step process. Just watch how that huge calculation completely melts away.
Here's our game plan. It's just 3 simple steps. First, we'll take each of those 3 big numbers and find its remainder when divided by 17. Then, we just multiply those small remainders together. That's really it.
Okay, let's apply our method. For 1736, we can see that 1700 is obviously divisible by 17, so we just need the remainder for 36 divided by 17, which is 2. Easy. For 3488, the remainder is 3. And for 17.2, since 17e is divisible by 17, the remainder is just 2. Now for step 3, the fun part. We just multiply those small numbers. 2 times 3 times 2 gives us 12.
And just like that, we have our answer. The remainder for that entire massive product is simply 12. No big multiplication, no calculators, no stress. See how powerful that shortcut is?
Now that was already really fast, right? But what if I told you there's another layer to this, kind of like a pro-level trick to make it even easier? This is where it gets really fun. We're going to talk about the concept of negative remainders. Now, I know it sounds a bit strange, but it's an incredibly clever tool to have in your back pocket for exam day. Trust me on this one.
Okay, let's break this down. With this simple example you see here, when you divide 44 by 7, you get 6 with a remainder of 2. That's the positive remainder we all know, but you could also say that 7 times 7 is 49. So how far is 44 from 49? Well, it's 5 times less. So the negative remainder is -5. It's just 2 ways of looking at the same thing.
So why even do this? Well, let's say you need the remainder of 67 divided by 17. The normal positive remainder is a pretty large number, 16. But think about the next multiple up. 17 times 4 is 68. And since 67 is 1 times less than 68, the negative remainder is just -1. Now, if you had to multiply this remainder with other numbers, which one would you rather use, 16 or -1? Yeah, the choice is obvious, right?
All right, let's tackle a new problem to see this all come together. We need the remainder for this product when we divide it by 17. Again, this is a total beast of a calculation if you do it the long way.
Okay, let's find our individual remainders. For 1539 divided by 17, the remainder is a nice small +5. For 687, it's +7, and for 1704, it's +4. Now notice here that all of these positive remainders are small, so using them is perfectly fine. But if one of them had been something big, like +16, we would have immediately used -1 instead. For now, let's stick with the positive path. 5 times 7 times 4 gives us 140. So our result, 140, is still bigger than our divisor, 17. But that's not a problem. It just means we have one final simple step. The rule still works. We just need to find the remainder of this new number. So we do one last easy division. What's the remainder when 140 is divided by 17? Well, we know that 17 times 8 is 136. So 140 minus 136 gives us a remainder of 4. And that is our final answer for the entire problem. It's a beautifully consistent system, isn't it?
So there you have it. You've just unlocked a new math superpower. Let's quickly summarize the key takeaways so you can walk into your next exam and use this with total confidence.
Just remember these rules. First, funnel all those big numbers down to their individual remainders and multiply them. Much easier. Second, choose your tool wisely. Use positive or negative remainders, whichever makes the calculation smaller and faster. And finally, if your result is still bigger than the divisor, don't worry. Just repeat the process and find the remainder again. It's a simple loop.
And you know, this quote really captures the spirit of what we just learned. We didn't do harder math. We just found a way to see the problem differently, to make a complicated-looking question incredibly simple.
And that leaves us with a fascinating thought. This rule feels like a magic trick, but it's pure mathematical logic. It kind of makes you wonder, right? What other math rules that we learn are really just elegant shortcuts